Question 1 asks you how many moles of oxygen atom in 25.7 gram of calcium sulfate. Here us the mass of calcium sulfate and ask moles of oxygen atom. Here mass, ask moles. You need immediately think about the chart I wrote here many times. Mass to moles is mass divided by molar mass. You get moles, right? So mass 25.7 gram. Calcium sulfate divided by molar mass. We need to figure out what is the molar mass of calcium sulfate by use periodic table. Periodic table, calcium 40.08, sulfur 32.06, oxygen 15.9994, just 16. So add these together. At the oxygen, you have 4 oxygen. You need to add 4 oxygen there.
I think you're doing the other class of quiz.
Oh, all right. Yeah, this is a 10 o'clock class. 10 o'clock class. Let's see. Sorry. Yeah. What is the mass? Oh, sorry. What is the mass of 2.5 more calcium carbonate? Okay. So this time tell us more. Also mass. So we still need to take a look at this chart. Tell us mass. Tell us moles. Also your mass. So opposite. Right. So more multiplied by molar mass. Yeah. So more multiplied by molar mass. More 2.5. Now what is a molar mass? We need to use periodic table. Periodic table tells us calcium 40.08 here. Carbon 4.01. Oxygen 16. You have 3 oxygen. Add them together. 1 calcium, 1 carbon, 3 oxygen. Add them together is 100 points. Calcium is 0.08. Carbon is 0.01. Okay, then 0.09 gram. Right. Then this will be approximately 250, right? So 250.2. Your choice is B. Question 2. Ask you how many molecules of water are there in 2.56 more water? So ask you how many molecules tell you moles we need. Use this chart again. So we need another half. From moles, find out the number of molecules or some substance, the atoms. So here us moles, ask molecules. More multiplied by Avogadro number. Avogadro number 6.022 times 10 to the 23rd power. I provide in the top of this sheet. Right. So 2.56 more times Avogadro number per mole. 6.22 times 10 to the 23rd power per mole. So per mole, concentrates more, you get molecular number. So use a calculator, you can easily get this is a 1.54 times 10 to the 24 power. So clearly your answer will be C. If you're smart enough for this question, you even don't need to calculate. Why? Because only choice C is a very big number, right? So whenever ask you how many molecules or how many atoms, always a very big number. If I give you only one choice, it's a very big number, then you don't need to calculate. But if I give you two very big number, you do need to calculate to judge which one is correct. I give you easiest choice. Only one extremely big number. Then you don't need to calculate because any more times Avogadro number always a very big number. Okay, question 3. I'll see how many moles of copper atoms are there in 2.85 gram copper. So ask you moles, but I tell you gram is mass, right? Tell us moles. No, tell us mass. Ask moles. Mass to moles. Right? So mass divided by molar mass. 2.85 gram copper divided by molar mass. Use the periodic table. Copper molar mass 63.55. Okay, 63.55 from periodic table. So 2.85 divided by 63.55. Your answer will be 0.0448. Choice is D. 4. Ask how many atoms of iron are there in 23.5 gram? So this time, tell us mass. Ask you how many atoms. Yeah. Tell us mass. Ask how many atoms. You need 2 steps, right? So mass first divided by molar mass, get more. Then multiply by Avogadro number, you get number of atoms. All right. 23.5 gram iron divided by molar mass. Take a look periodic table. The iron here, 55.85. 55.85 gram, or 1 more iron. So you get moles. Then from mole, convert to number of atoms multiplied by Avogadro number. 6.022 times 10 to the 23 is power. So again, whenever ask you how many atoms or how many molecules, your answer always be a very big number, right? Again, I only give you one very big number. Then you don't need a calculator. That is a choice. Some of you smiling. This I give easiest choice. Your choice will be D. Then question 5. Also is the percentage of iron in compound Fe2O3. Okay, percent composition. So as we have formula, we can always calculate the percent composition for any compound, right? Fe2O3. That means you have 2 Fe, right? 2 Fe from periodic table. Fe, the mass number Fe is 55.85, and O is 60. Fe 55.85. Denominator 2 Fe plus 3 oxygen, each oxygen 16 times 100%. This give you a percentage is 69.94. Okay. So your choice is B. This is not as easy as one biggest number. It just shows that. This you do need to calculate. Then how about A? Some of you choose A. 66.67. If you choose A, this means you use 2 out of 3, right? 2 out of 3 is 66.67. Cannot be so easy. Use 2 out of 3. This is an atom ratio. It's not the percent composition. We have more than one student choose A 66.67. This means you didn't lesson in the class. We have this example shoot the class. Question 6. Tell you empirical formula of a compound is CH, and the molar mass of the compound is about 84. Ask you what is the molecular formula? We also shared the example during the class, right? So what's the difference between empirical formula and molecular formula? The definition is empirical formula is symbol is the whole number ratio of atoms from each element, while molecular formula tell us exact number of atoms from each element.
It says CH2 on the paper.
CH2 in the paper, yes, sorry. Yeah, empirical formula is CH2. So from definition, empirical formula is symbol is the whole number ratio of atoms from each element, and molecular formula tells the exact number of atoms from each element. Their difference actually is a whole number, because from exact number of atoms from each element to the symbol is the whole number ratio of atoms from each element is you just divide it by a whole number, right? Like you remember we have this example, sugar, glucose, C6H12O6 molecular formula. How can we get is the empirical formula? Everybody divided by 6, right? CH2O. So this is the empirical formula. This is the molecular formula. What's the difference? The difference is the whole number 6, right? So now tell us empirical formula. We need to get back to molecular formula. Our job is actually to find this whole number, right? This is opposite. How can we find this whole number? Then we need to use these two conditions. Molecular formula, molar mass is 84. Then what is the molar mass for this empirical formula? Then we compare these two molar mass will give you a whole number. Okay. So empirical formula's molar mass equal to what? CH2. Use periodic table. C is 12, right? Carbon mass number 12. Hydrogen is 1. 14, right? Then what is the whole number? So clearly 84 compared with 14 is 6. Then molecular formula will be CH2 times 6. This will be the molecular formula. Get it? Okay. So your choice will be B. C6H12. Okay. Can you understand this? I can tell you we will have similar question in the test. It's all test in the quiz here. These are all essential, are required content. Question 7. Question 7, not multiple choice. This is balance equation. A and OH react with sulfuric acid, use water and sodium sulfate. Okay. To balance the equation, the rule is we balance those atoms here one time in each side, right? This is a general rule, right? For some specific reaction, this is the one. This acid, sulfuric acid, right? This is the one. Base, right? Acid react with base. The critical reaction is based on one hydrogen ion react with one hydroxide ion, produce one water. This is a critical thing. Whenever you see a reaction is between acid and a base, just remember this. Then balance the equation is very easy. Okay. So one hydrogen ion react with one hydroxide ion, produce one water. Then if two hydrogen ion must have two hydroxide ion, produce two water. Right? How many hydrogen? Two. H2SO4. This is two hydrogen ion. Then you need to have two hydroxide ion. Must have two hydroxide ion and produce two water. Right? So two hydrogen ion, two hydroxide ion produce two water. The rest is two sodium and one SO4. Are these two balanced? Yes. Two sodium, one SO4. Already balanced. So this example tell you whenever next time you see balance equation is about acid base reaction, just remember this. One hydrogen ion react with one hydroxide ion, produce one water. Okay. Then for any acid base reaction, you can easily balance that equation. B. CO react with O2, produce CO2. This is not acid-base reaction. We need to use general rule, balance equations. Balance those elements show up only one time in each side. For this reaction, only two elements, carbon and oxygen, right? Only carbon show one time. Oxygen, this side is two. Right? Two compounds, both have oxygen. So balance carbon first. Carbon already balanced. Right? Oxygen not balanced. Then you have to balance oxygen. Oxygen, this is two, this is one. Total three. And this side is two. Two and three, how can we balance? Of course, we need to make this one become the even number. Because any one, any number in front of this, you can only change in front, right? So you can change it to 2, 3, no number means 1. Whatever number you put in the right side, this oxygen number always even number because this already have 2 there. Even if you put the even number, odd number 3, still 6 is the even number, right? That means left side you must put some even number in front of this to be able to balance both sides, right? So for the even number, small is 2, right? Small is the 2, so 2 oxygen, another 2 oxygen, 4 oxygen. 2, then you need to times 2 to 4. So 2 oxygen plus 2 oxygen is 4. 2 times 2 is 4. Is carbon balanced? Yes, water balanced. Question 7. Question 8. This is most problem. Many of you got lost, except for those made 20 out of 20. Okay? Many of you got lost. Some didn't do anything. Question 8. Okay, so listen carefully. This is about calculate theoretical yield, figure out limiting region first, then calculate theoretical yield, then calculate percent yield. So the reaction is aluminum react with Cr2O3, produce Al2O3 and 2 chromium. Here you is 55 gram Cr2O3 mixed with 16 gram of aluminum. Ask you which region is limiting region. Which is a limited region? Of course, either this or this. Limited region always reactant, cannot be product. Okay, so either this or this. To figure out the limiting region, we can pick any one of these reactants to calculate how much of the other reactant needed, then compare with the amount it have to find which one is the limited region. We can pick this or this. So if I pick Cr2O3 reactant, then we can calculate how much Al needed. So mass always converted to mole first. Mass divided by molar mass, right? Mass divided by molar mass, you get a moles. What is the molar mass? By use periodic table. Okay, Cr molar mass is 52. Cr is here. 51.996 is 52. Oxygen 16. Okay, so 2 Cr, 3 oxygen. Add them together, 152. So mass divided by molar mass, you get a moles. Moles, then use this balanced equation. For every 1 mole, new number means 1. Every 1 mole Cr2O3 need 2 more aluminum. Now the question is, you put 2 in top or in bottom? Top, yes, because you want more of Al. They must be top. So more of Cr2O3 cancelled, left over more of aluminum. And that's it, or we need to continue? We need to continue because here is more, there's more aluminum, but here is mass. More cannot compare with mass directly. 2 quantity must be in same unit, right? So more convert back to mass, then compare this mass. More multiply by molar mass, then aluminum molar mass, the periodic table tells us 26.98. 26.98 gram aluminum. 1 more aluminum. Then this is the mass. This mass is 19.52 gram. This is the amount needed. Then how much we have? 16. We need 19.5 too, but we only have 16. What does this mean? Yes, aluminum is a limiting reagent. It's not enough, right? So Al is a limiting reagent. You may see, another one you pick a Cr2O3, you find the aluminum reagent is the aluminum. And if I pick 16 gram of aluminum, then which one is the limiting reagent? I can assure you, your answer will be same, still aluminum. Okay. If you pick a 16 gram of aluminum react, then you need divide by molar mass of divide by molar mass. Then compare with this, choose this balance equations, divide by 2 becomes moles of Cl2O3, becomes moles of Cr2O3. Then multiply by molar mass of this 152, the mass will be less than 55, I can assure you. Less than 55, this means this guy is excess reagent. The aluminum still the limit reagent. So your conclusion will be same. That's why I say you can pick any one of the two reactants, find out the limit reagent. Okay. You get it? It's not matter you pick one, pick which one. Your conclusion is same. Calculation is similar, just mass divided by molar mass, then use balance equation to find the moles of the other one, then multiply by molar mass of that one, compare with the mass we have. Okay. Are you okay for this? Okay. So this is A, then B. Theoretic yield. So since aluminum is a limited reagent, now you don't have a choice. You must use a limiting reagent to calculate the theoretic yield. Okay, because excess reagent is somewhat left. You cannot use excess reagent to calculate theoretic yield. So aluminum is a limiting reagent, 16 gram aluminum. Mass always convert to mole. Divided by molar mass. Then use this balance equation again. Every 2 more aluminum produce 2 more chromium. So 2 more chromium, 2 more aluminum. Aluminum becomes urge. So far we get more chromium. More is not the theoretic yield. Theoretic yield is mass, so we need to multiply by molar mass. Chromium, molar mass is 52 gram. So we get 30.84 gram. Then we can calculate the theoretic yield. Theoretic yield is the actual yield divided by theoretic yield. Theoretic yield we just calculated. So 30.84. Actual yield tells you. Here tell you the actual yield is 24.3 gram. This always tell you, you cannot calculate the wrong experiment, collect the product. 24.3. Theoretic yield is 30.84. Is 78.8%. Because this, yeah, actually here is the 4 significant figure. This is also 4 significant figure. Then we kept 4 significant figure. 78.79%. Okay, are you okay? Do you have any other question? No other question? No other question. Then we come back to chapter